maximum rates of change. I'll be presenting both graphically and a bit of summary algebraically as well for you to have a clear understanding of what this concept really means. So as you can see on the screen, we have two types of maximum rates of change. So when you're trying to do the questions, you have to read the questions with a lot of care as to does the assessor wants you to tell them the value of t for time, for instance, to give the maximum rate of increase, or the value of time that will give the maximum rate of decrease, for instance. So now I made a little summary here for you. At the moment, it may not make very much sense, but I would like you to pause the video here and jot down this information so that you can come back to it, and it will help you to understand when we see the graph. So let's just have a read. So the first type is, in order for you to work out the maximum rate of increase, it simply means the absolute maximum value of the gradient function over that particular interval. And then if you want to work at the maximum rate of decrease, it simply means the absolute minimum value of your gradient function over the specified domain. So let's, and this is another sort of like quick way or little quick summary that you can actually do this by inspection as well, which I would like you to again jot this down, and so that we can come back to it and take a look at it. So let's go into the graph. So pretend this is the graph of f of x given to you here. It's just a segment of a negative cosine function, that's all. And there are a couple of points of interest. So we have point A, B, C, D, and E. And our job here is that we need to work out, or we need to try to locate, where is it at which point along this segment of your cosine function that will going to give you the maximum rate of increase and the maximum rate of decrease. So as you've learned from calculus, if you were to differentiate this cosine function, that will basically correspond to the instantaneous rate of change at different t values along here. And if you were to draw, say, tangent lines along different segment or different parts of this f of x curve, you will tell that the gradient will change. So let me just do a little demo here for you. So I'm just going to pull out my tangent line here. So I'm going to place my tangent line here. As you can see here, your tangent is actually at 0 because clearly at A is a turning point. And if I were to move my tangent lines around, can you see here that the value or the steepness of the slope of my tangent line, so just take a look at, say here, the slope of my tangent line is 1.44. And if you have a look at it, the more I move up here, can you see that is actually increasing in a positive direction? Increasing still, getting bigger and bigger and bigger and bigger and bigger and bigger. Now at point B is actually at 3.14, and I continue, you can see now it's dropping. I've just passed point B. So in terms of point B, the coordinates is at 1 and 2, if you follow my grid. And now if I were to continue to go, further and further and further up towards point C, the slope of my tangent line is actually getting a little bit smaller, and now when I'm back at C, it's 0. Okay, so we're going to have a look at this segment here. So as you can see down here, let me just escape out of my tangent line here. Let's just investigate the slope. So at point A, I did the summary here, slope is 0, correct? And now, if I'm going to move my tangent lines towards point B, can you see that I'm actually more at B is actually even more positive than what it was here? So more positive and more positive. and at C. So we're only going to talk about between A and B here, all right, to make it easy. So we're going from 0, as you can see here. I did the summary for you in the conclusion. At point A, it's at 0, but obviously it's getting towards point B. It's getting steeper and steeper and steeper, and it reaches the steepest point at B, which I said, it's the positive, the slope at point B is very positive here, plus, plus, very positive, all right? So you must agree with me that if you're going from 0 to very, very, very positive, it's fair for me to say that the slope of my tangent line, or my instantaneous rate of change, is actually increasing. So therefore, if it's increasing, let's go back to here, all right? So now, if you look at here, the maximum rate of increase, I did a little summary here before. The best way for you to remember this is pretty much it's the midway, all right, between your minimum turning point, stationary points, and your maximum, isn't that right? So this is my minimum right here, and this is my maximum up here. And clearly at point B, we've discovered before with drawing our tangent lines along the curve, this is the steepest point. And so therefore at B, this is what we call, all right, as the maximum rate of increase. Now, the same thing, what I'm going to do is I'm going to go back to this graph and I'm going to draw the corresponding derivative graph on the same set of axes for you to see it a little bit clearer. So in order for you to draw the derivative, what you do is you go shift negative for me, X, and I'll see tab, and in here I will select f of 1, hit enter. All right. So in red, this is the corresponding instantaneous rate of change, or the derivative graph. And now, as you can see at point B, meaning, so pretend this is the horizontal, it's time, at time equal to 1 unit, it corresponds to the biggest, or what we call the absolute maximum value of your derivative function, which I made the little summary here for you earlier. So the first type is what? In order for you to determine the maximum rate of increase, it simply equals to the absolute maximum value of your gradient function. So your gradient function is in red here, as you can see, and at time equals to 1 unit, this is my absolute maximum value. All right, so that's what it means by maximum rate of increase. Now we're going to move and have a look at the maximum rate of decrease now. So let's investigate. Let's go back to the blue curve again. So at point C, all right, the slope is 0, correct? And now if I'm going to draw my tangent line, I'm going to pull out my tangent line again. Okay. All right. Now, at point C, we can see that the slope, not quite there yet, anyway, a bit fiddly here. So at C, it's almost 0. And then now, if I could drag my tangent lines, remember, the slope of my tangent line corresponds to the instantaneous rate of change. So as we can see here, it's getting smaller and smaller and smaller, and so meaning very negative, very negative, very negative, even every negative, very negative, as you can see here. And at point D, it's very negative, very small. But however, though, if I pass point D, can you see that I'm actually less negative? Yeah? Okay. So therefore now, if you consider the segment between point C to point E, you can see similar arguments to what we said before. It's the steepest point is around this region, and obviously the most steepest, or the smallest negative value, is at D, correct? So now, in order for you to draw conclusions, though, as I did here, the slope at D is very negative, and obviously at E, it basically turns back to 0. So when it comes to writing the conclusion here, if I'm going from 0 slope and I'm getting very negative and very, very negative, getting smaller and smaller, meaning to very negative here, you must agree with me that the slope or the rate is actually decreasing. So therefore, I can conclude that at point D, we're going to give me, all right, the maximum rate of decrease, right? And pretend that this is time. So the maximum rate of decrease, it will going to be occur at time, that's 1, that's 2, so the grid here, at time t equals to 3. Isn't that right? All right. So therefore now this is just writing conclusion. So the maximum rate of increase must be when t equals to 1. And here your minimum rate of decrease must be when t equals to 3, isn't it? So now let's just back it up again to the other two summaries that I showed you before. So now I said here, the maximum rate of decrease simply equals to the midway between your maximum and your minimum. You must agree with me, right? This is your maximum and this is your minimum, and at D, this is where the maximum rate of decrease we're going to be. So that's one way to do it. Alternatively, look back at the other summary that I put. So the maximum rate of decrease simply equals to the absolute minimum value of your gradient function. So now my gradient function was in red here, and as you can see at t equals to 3, which is right here, your gradient function in red, you must agree with me that this point right here is the lowest point, isn't that right? And that is pretty much in terms of what I want you, the theory behind this, girls. So I would like you to watch this video like a couple of times if you still don't quite get it. And what I want you to do is to copy down these two summaries and put it in your bound reference somewhere. So that will going to become very handy. And if you were to would like to have another practice or trying to get your head around this, I would like you to turn to your textbook on page 452, example 31, which basically gives you, a question that is exactly like what I just demonstrated. And also too, in our practice sack, the Dorothy Smart practice sack, we did ask you about this maximum rates of change as well. So that's something for you to have a practice. So that is the end of my tutorial. Good luck.